Apiculture, also known as beekeeping, is the practice of raising and managing honeybees for the production of honey, beeswax, pollen, royal jelly, and other bee-related products. It is an ancient agricultural activity that dates back thousands of years and is still widely practiced today. Beekeeping not only provides valuable products but also plays a crucial role in pollination and the preservation of bee populations. Species of honey bees. In India, there are several types of honey bees commonly found. The most prominent and widely recognized species is Apis mellifera, also known as the European honey bee. However, India is also home to several indigenous species of honey bees, which have adapted to the diverse climatic conditions and floral resources of the country. Here are some of the notable honey bee species found in India: Apis dorsata or rock bee. Apis dorsata, commonly known as the rock bee or giant honey bee, is a large-sized honeybee species found in the wild throughout India. They typically build their nests on cliffs, trees, and other elevated structures. Rock bees are known for their aggressive defense behavior when their nests are disturbed. They produce a significant amount of honey and beeswax. Apis cerana indica or Indian honey bee. Apis cerana indica, or the Indian honey bee, is a subspecies of the Asian honey bee, Apis cerana. They are widely distributed across India and are known for their adaptability to diverse climatic conditions. Indian honey bees are smaller in size compared to Apis mellifera and are known for their agility and ability to forage on a wide variety of flowering plants. Apis florea or little bee. Apis florea, commonly referred to as the little bee or dwarf honey bee, is a small-sized honeybee species found in India. They build small nests in tree branches, crevices, or even in the eaves of houses. Little bees are known for their ability to exploit a wide range of floral resources and their swarming behavior. Apis laboriosa or Himalayan honey bee. Apis laboriosa, also known as the Himalayan honey bee, is a species found in the higher altitudes of the Himalayan region. They are known for their large nest structures built on the sides of cliffs or on tall trees. Himalayan honey bees are considered vital for pollinating high-altitude flora and are known for producing a unique honey called mad honey. Apis mellifera or European honey bee, although not native to India, Apis mellifera, the European honey bee, has been introduced in certain regions for commercial beekeeping. They are known for their high honey production and gentle behavior, making them popular among beekeepers. It's important to note that bee populations can vary across different regions of India. And there may be other local or regional species of honey bees that are not mentioned here. The diversity of honeybee species in India contributes to the country's rich apicultural heritage and the availability of various types of honey with distinct flavors and characteristics. The organization of a honeybee colony is highly structured and consists of various individuals with specialized roles and responsibilities. The colony operates as a cohesive unit, with each member contributing to the survival and success of the entire group. Here is a detailed explanation of the organization of a honeybee colony. Queen bee. At the top of the social hierarchy is the queen bee. There is only one queen bee in a colony, and her primary role is reproduction. She is larger than other bees and has a longer abdomen. The queen bee mates early in her life and stores enough sperm to fertilize eggs throughout her lifespan, which can be up to 5 years. Her main tasks include laying eggs, secreting pheromones to maintain colony cohesion, and regulating the development of worker bees. Worker bees. The majority of bees in a colony are worker bees, which are all females. Worker bees perform a wide range of tasks throughout their lifespan, progressing through various roles as they age. The different tasks include nurse bees. Young worker bees start their lives as nurse bees. They care for the brood, eggs, larvae, and pupae, feed them with a mixture of pollen and royal jelly, and maintain the overall cleanliness of the hive. Forager bees. As worker bees age, they become foragers. Foragers leave the hive in search of nectar, pollen, water, and propolis, a sticky substance used for hive construction. They navigate using visual cues and communicate the location of food sources through a dance known as the waggle dance. Foragers are crucial for collecting resources for the colony's survival. Guard bees. guard bees protect the entrance of the hive from intruders, such as other bees, wasps, or predators. They inspect incoming bees and detect any potential threats. Undertaker bees, bees that specialize in removing dead bees or other debris from the hive are called undertaker bees. They play a vital role in maintaining hygiene within the colony. Builder bees, when the hive needs expansion or repair, worker bees take on the task of building honeycomb and repairing any damaged areas. They use beeswax, which they produce from glands on their abdomen, to construct the intricate hexagonal cells of the honeycomb. Hive temperature regulators, worker bees also work together to regulate the temperature inside the hive. They use their wings to fan and regenerate heat, maintaining an optimal temperature for the brood and honey storage. Worker bees, the majority of bees in a colony are worker bees, which are all females. Worker bees perform a wide range of tasks throughout their lifespan, progressing through various roles as they age. The different tasks include: nurse bees. Young worker bees start their lives as nurse bees. They care for the brood, eggs, larvae, and pupae, feed them with a mixture of pollen and royal jelly, and maintain the overall cleanliness of the hive. Forager bees, as worker bees age, they become foragers. Foragers leave the hive in search of nectar, pollen, water, and propolis, a sticky substance used for hive construction. They navigate using visual cues and communicate the location of food sources through a dance known as the waggle dance. Foragers are crucial for collecting resources for the colony's survival. Guard bees protect the entrance of the hive from intruders, such as other bees, wasps, or predators. They inspect incoming bees and detect any potential threats. Undertaker bees, bees that specialize in removing dead bees or other debris from the hive are called undertaker bees. They play a vital role in maintaining hygiene within the colony. Builder bees, when the hive needs expansion or repair, worker bees take on the task of building honeycomb and repairing any damaged areas. They use beeswax, which they produce from glands on their abdomen, to construct the intricate hexagonal cells of the honeycomb. Hive temperature regulators, worker bees also work together to regulate the temperature inside the hive. They use their wings to fan and regenerate heat, maintaining an optimal temperature for the brood and honey storage. Drones are male bees, and their primary purpose is to mate with virgin queens from other colonies. They do not have stingers and lack the ability to forage or perform other tasks within the colony. Drones are produced during the breeding season and are expelled from the hive in the fall when resources become scarce. Brood, the brood refers to the developing stages of honey bees, including eggs, larvae, and pupae. The queen bee lays eggs in the cells of the honeycomb, and the worker bees care for the brood by feeding and grooming them. The brood requires a specific temperature and humidity to develop properly, so worker bees adjust the hive conditions accordingly. Hierarchy in communication. The organization of a honeybee colony is highly structured, with clear communication and hierarchy. Bees communicate through chemical signals called pheromones, as well as tactile and visual cues. The queen bee emits pheromones to maintain colony unity and regulate the behavior of other bees. Worker bees communicate the location of food sources through the waggle dance and use pheromones to transmit various messages within the colony. Overall, the organization of a honeybee colony is a complex system. Beekeeping, also known as apiculture, involves the management and care of bee colonies for various purposes such as honey production, pollination of crops, and beeswax collection. There are several methods and techniques used in beekeeping, depending on the goals and preferences of the beekeeper. Here is a detailed explanation of some common beekeeping methods. Hive types. Beekeepers use different hive types, each with its own advantages and characteristics. The two most widely used hive types are Langstroth hives. Langstroth hives consist of rectangular boxes stacked vertically, with removable frames inside. The frames hold beeswax honeycomb, and beekeepers can easily inspect and manipulate the frames without disturbing the entire colony. This hive type provides efficient management, easy honey extraction, and promotes colony growth. Top bar hives. Top bar hives have horizontal bars instead of frames. The bees build comb downward from the bars, and the beekeeper can harvest honey by removing individual bars. Top bar hives are relatively simpler and less expensive, making them suitable for small-scale beekeeping or beekeepers who prefer a more natural approach. Hive placement: beehives should be strategically placed to optimize foraging opportunities and minimize potential disturbances. Factors to consider include shelter. Hives should be placed in a sheltered location to protect them from extreme weather conditions, such as strong winds or direct sunlight. Orientation: the entrance of the hive should face south or southeast to maximize exposure to the morning sun, which helps stimulate bee activity and early foraging. Accessibility: beekeepers should have easy access to the hive for regular inspections, maintenance, and honey extraction. Water source: a nearby water source, such as a pond or a shallow container with fresh water, is important for the bees' hydration. Colony management: effective colony management is crucial for the health and productivity of the bee colonies. Key management practices include hive inspections. Regular inspections of the hive allow beekeepers to monitor the health of the colony, check for diseases or pests, assess honey stores, and ensure sufficient space for colony growth. Feeding: bees may require supplemental feeding, especially during periods of nectar scarcity or in the early stages of colony establishment. Sugar syrup or pollen substitutes can be provided to ensure the bees have enough food. Swarm prevention: swarming is a natural reproductive process of honey bees. To prevent swarming, beekeepers may employ techniques such as providing additional space in the hive, removing queen cells, or splitting the colony into multiple hives. Pest and disease control: beekeepers need to monitor and control pests and diseases that can affect the health of the colony. Common pests include varroa mites, wax moths, and small hive beetles. Integrated pest management (IPM) techniques, including the use of organic treatments or selective breeding, can be employed. Honey extraction: honey extraction is the process of harvesting honey from the honeycomb. It involves several steps: removing supers. Supers are additional boxes placed on top of the hive that contain the honeycomb. These supers are removed from the hive and taken to the honey extraction area. Uncapping: the wax cappings covering the cells of the honeycomb are removed using a hot knife or an uncapping fork. Exposing the honey extraction: the uncapped frames are then placed in a honey extractor, a centrifuge that uses centrifugal force to spin out the honey from the comb. Straining and bottling: the extracted honey is strained to remove any remaining debris or wax particles. It is then transferred to clean jars or containers for storage and eventual sale or consumption. Bee veil and protective clothing: beekeepers wear protective clothing to shield themselves from bee stings. This typically includes a bee veil, which is a mesh fabric attached to a hat or helmet, protecting the face and neck. Additionally, beekeepers may wear beekeeping suits, gloves, and boots for further protection. Bee brush: a bee brush is a soft bristled brush used to gently move bees from frames or hive components during inspections. It helps in clearing bees away without harming them. Hive tool: a hive tool is a versatile tool used for prying apart hive components, scraping propolis and wax, and removing frames. It has a flat, narrow, and slightly curved blade on one end and a hooked or chiseled edge on the other. Extractor: an extractor is a machine used to extract honey from honeycomb. It uses centrifugal force to spin the frames, separating the honey from the comb. Extractors can be manual or electric, and they come in various sizes. Honey storage containers: containers such as jars, buckets, or barrels are used for storing harvested honey. They should be food grade, airtight, and resistant to moisture to maintain the quality and freshness of the honey. These are some of the fundamental beekeeping equipment used by beekeepers. Depending on the specific beekeeping methods, hive types, and personal preferences, additional equipment such as feeders, swarm boxes, pollen traps, and queen rearing equipment may also be employed. Queen management: maintaining a healthy and productive queen is essential for the overall performance of the colony. Beekeepers may choose to requeen colonies periodically to ensure optimal genetics, productivity, and disease resistance. Techniques such as queen grafting, introducing mated queens, or raising queens from selected colonies may be used for queen management. hive component maintenance. Regularly maintaining hive components is important for the longevity and functionality of the equipment. This may involve replacing old or damaged frames, cleaning and sterilizing hive components, repairing or replacing damaged supers or bottom boards, and ensuring proper ventilation. Harvesting and extracting honey. When the honey flow is abundant, beekeepers need to monitor honey stores and determine the appropriate time for honey harvesting. Honey extraction involves carefully removing frames from the hive, uncapping the honeycomb, and using an extractor to spin out the honey. Proper hygiene and storage of extracted honey are necessary to maintain its quality. Record keeping. Maintaining accurate records is beneficial for tracking hive health, productivity, and management practices. Record keeping may include hive inspection notes, honey yields, pest and disease observations, queen-related information, and any treatments or interventions performed. These records help beekeepers track colony performance, identify patterns, and make informed management decisions. Continued education and learning. Apiary management is an ongoing learning process. Beekeepers should stay updated on the latest research, advancements, and best practices in beekeeping. Participating in workshops, joining beekeeping associations, attending conferences, and engaging with other beekeepers can provide valuable knowledge and networking opportunities. Environmental considerations. Beekeepers should be mindful of the surrounding environment and promote bee-friendly practices. This includes avoiding or minimizing pesticide use near the apiary, providing diverse forage sources, and contributing to pollinator-friendly landscapes. Creating a healthy and sustainable environment benefits the bees and the overall ecosystem. By implementing these practices, beekeepers can effectively manage and maintain their apiaries, fostering strong and thriving bee colonies. Bee pasturage, also known as bee forage or bee flora, refers to the variety of flowering plants from which bees collect nectar and pollen. It plays a crucial role in providing nutrition for honey bees and other pollinators, supporting their health, growth, and honey production. Beekeepers often consider the availability and quality of bee pasturage when managing their apiaries. Here are some key aspects related to bee pasturage. Types of bee pasturage. Bee pasturage encompasses a wide range of plant species, including wildflowers, flowering trees, shrubs, agricultural crops, and garden plants. Bees require a diverse range of nectar and pollen sources to meet their nutritional needs throughout the year. Different plant species bloom at different times, providing a continuous supply of food for bees. Native plants and wildflowers. Native plants and wildflowers are typically well adapted to the local environment and often provide excellent bee pasturage. They can include various species such as clover, aster, goldenrod, sunflowers, milkweed, and many others. These plants not only provide nectar and pollen but also support local ecosystems and biodiversity. Flowering trees and shrubs. Many flowering trees and shrubs are valuable sources of bee pasturage. Examples include fruit trees, apple, cherry, peach, willows, poplars, basswood, black locust, and heather. These plants often produce abundant flowers, attracting bees with their nectar and pollen. Agricultural crops. Certain agricultural crops serve as significant sources of bee pasturage, supporting both honey production and crop pollination. Examples include alfalfa, clover, canola, sunflowers, buckwheat, and various fruit and vegetable crops. Beekeepers may collaborate with farmers to provide pollination services, and in return, their bees benefit from the abundant nectar and pollen available in these crops. Garden plants and herbs. Many garden plants and herbs are attractive to bees and can be grown in home gardens or community spaces to support local pollinators. Flowers such as lavender, borage, marigold, zinnia, and salvia are popular choices. Growing a variety of flowering plants in gardens helps provide additional food sources and improves bee diversity. Seasonal availability. Bee pasturage availability varies throughout the year, depending on the flowering patterns of different plants. Spring and summer typically offer a wide array of flowering plants, providing ample nectar and pollen for bee colonies. Fall may have a more limited selection, but late flowering plants like asters and goldenrod can provide important food sources before winter. Supplemental feeding. In regions or periods when natural bee pasturage is scarce, beekeepers may need to provide supplemental feeding to ensure their colonies have enough food. Sugar syrup or pollen substitutes can be provided to sustain the bees until natural forage becomes available. Pollinator-friendly landscaping. Creating pollinator-friendly landscapes involves planting a variety of bee-friendly flowers and providing habitat features such as nesting sites, water sources, and shelter. By incorporating bee pasturage plants into gardens, parks, and other green spaces, individuals can support local bee populations and promote ecosystem health. Environmental considerations. Bee pasturage should be free from or minimally impacted by chemical pesticides. Pesticide use can be harmful to bees and other pollinators. Beekeepers and landowners should follow responsible pesticide practices to protect bee health and the integrity of bee pasturage, understanding the availability, quality, and seasonal patterns of bee pasturage is essential for beekeepers to ensure their colonies have sufficient food resources for proper growth, honey production, and overall colony health. By promoting diverse and abundant bee pasturage, beekeepers contribute to the well-being of their bees and help sustain pollinator populations. Byproducts of honey bees and their uses. Honey bees produce several valuable byproducts in addition to honey. These byproducts have various uses and applications in different industries. Here are some of the key byproducts of honey bees and their uses. Beeswax. Beeswax is a natural wax produced by honey bees to build their honeycomb. It has numerous applications, including candle making. Beeswax candles are highly prized for their clean burning properties, long burn times, and pleasant aroma. Cosmetics and skin care. Beeswax is used in various skin care products, such as lip balms, lotions, creams, and soaps, due to its moisturizing and protective properties. Woodworking and furniture polish. Beeswax is used to make furniture polish and as a natural wood finish for preserving and protecting wood surfaces. Crafts and art. Beeswax is utilized in encaustic painting, a technique that involves using pigments mixed with melted beeswax to create artworks. Propolis. Propolis is a sticky resinous substance collected by bees from tree buds, sap flows, and other botanical sources. Bees use propolis to seal and strengthen their hives. Its uses include health supplements. Propolis is believed to have antibacterial, antifungal, and antioxidant properties. It is available in the form of tinctures, capsules, and extracts as a natural health supplement. Cosmetics. Propolis is used in skin care products, such as creams, ointments, and serums, for its potential benefits in promoting skin health and reducing inflammation. Dental products. Propolis is found in some toothpaste, mouthwashes, and oral care products due to its potential antimicrobial properties and ability to support oral health. Royal jelly. Royal jelly is a secretion produced by worker bees and fed exclusively to the queen bee throughout her life. It is highly nutritious and has potential health benefits. Its uses include health supplements. Royal jelly is consumed as a dietary supplement due to its potential antioxidant and immune-boosting properties. It is available in capsules, powders, and liquid forms. Cosmetics. Royal jelly is used in some skin care products for its moisturizing and rejuvenating properties. It can be found in creams, serums, and facial masks. Bee pollen. Bee pollen consists of pollen grains collected by bees from flowers. It is packed with nutrients and is considered a complete protein source. Its uses include dietary supplements. Bee pollen is consumed as a nutritional supplement due to its high protein content, vitamins, minerals, and antioxidants. It is available in granules, capsules, and powders. Natural remedies. Some traditional medicine practices use bee pollen for various health conditions, such as allergies, digestive issues, and boosting energy levels. Venom. Bee venom is the substance that bees inject when they sting. It contains a mixture of compounds that can have therapeutic effects. Its uses include apitherapy. Bee venom therapy involves controlled administration of bee stings for various health conditions, such as arthritis, multiple sclerosis, and chronic pain. It is used in alternative and complementary medicine practices. Cosmetics. Bee venom is used in some skin care products due to its potential anti-inflammatory and collagen-stimulating properties. It is believed to have benefits for skin tightening and wrinkle reduction. These are some of the primary byproducts of honeybees and their diverse uses across industries ranging from food and health to cosmetics and crafts. It's important to note that some of these uses may have limited scientific evidence and should be approached with caution or under the guidance of professionals. Honeybees can be affected by various diseases and pests that can significantly impact the health and productivity of their colonies. Here are some common diseases and pests of honeybees, along with control measures employed by beekeepers. Varroa mites, Varroa destructor. Varroa mites are external parasites that feed on honeybee brood and adults. They weaken the bees, transmit viruses, and can lead to colony collapse if left unmanaged. Control measures include chemical treatments. Beekeepers may use approved acaricides to control Varroa mite populations. These treatments are usually applied during specific times of the year following label instructions and recommended thresholds. Integrated pest management, IPM strategies involve a combination of methods, such as screened bottom boards, drone brood trapping, and the use of resistant bee stocks, to manage Varroa mites while minimizing the use of chemical treatments. Nosema, Nosema apis and Nosema ceranae. Nosema is a fungal infection that affects the honeybee gut. It can weaken the colony and reduce productivity. Control measures include medications. Beekeepers can use antimicrobial medications approved for the treatment of nosema, such as fumagillin, to control the infection. These medications are typically administered in spring or fall. Good hygiene practices, maintaining clean and dry hives. Reducing stress on the bees, and providing adequate nutrition can help prevent and manage nosema infections. American foulbrood, Pinabacillus larvae. American foulbrood, AFB, is a highly contagious bacterial disease that affects honeybee brood. It can lead to the death of infected larvae and the collapse of entire colonies. Control measures include destruction of infected hives. Hives infected with AFB must be destroyed to prevent the spread of the disease. Beekeepers must follow local regulations and guidelines for proper disposal, disease prevention. Good hive management practices, such as regular inspections, prompt removal and destruction of infected brood, and hygienic handling of equipment, can help prevent the spread of AFB. European foulbrood, Melissococcus plutonius. European foulbrood, EFB, is another bacterial disease that affects honeybee brood. It can weaken colonies and impact honey production. Control measures include antibiotic treatments. Antibiotics approved for EFB treatment, such as oxytetracycline, may be used to control the infection. These treatments should be administered following label instructions and under veterinary guidance. Hive management, maintaining strong and healthy colonies, practicing good hygiene, and ensuring proper nutrition can help prevent and manage EFB outbreaks. Small hive beetle, Ethena tumida. Small hive beetles are pests that infest honeybee colonies, particularly weak or stressed ones. They can damage combs, contaminate honey, and cause colony decline. Control measures include beetle traps. Beetle traps, such as oil traps or beetle blaster traps, can be placed in hives to capture and control small hive beetles. Strong colonies, maintaining strong and healthy colonies through good management practices, such as proper nutrition and regular inspections, can help bees fend off small hive beetle infestations. Wax moths, Galleria melanella and Acroia gracella. Wax moths are pests that can infest beehives, primarily targeting unused combs or weak colonies. They destroy beeswax, honeycomb, and pollen stores. Control measures include proper storage. Unused combs and equipment should be stored in a cool, dry, and well-ventilated area to prevent wax moth infestations. Strong colonies. Maintaining strong colonies with healthy populations can help bees defend against wax moth infestations. Regular hive inspections can help detect and address any weak or infested colonies. In addition to these specific diseases and pests, beekeepers also focus on general colony health management practices, such as providing proper nutrition, reducing stressors, maintaining good sanitation, and monitoring the overall health and productivity of the colonies. Regular hive inspections, record keeping, and staying informed about best practices and research advancements are vital for effective disease and pest management.